Okay, definition and terminology for Unit 1, Engineering Mechanics, Classifications and Laws of Mechanics. This is Dr. D. Govardhan, Professor in Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. The mechanics is a branch of science which deals with the behavior of the body when the body is at rest or motions under the action of forces. The engineering mechanics is a branch of applied science which deals with the laws of principles of mechanics along with their applications to engineering fields. The engineering mechanics is classified into two types, statics and dynamics. The statics is a branch of engineering mechanics which deals with the forces and their effects when the body is at rest. The dynamics is the branch of engineering mechanics which deal with the forces and their effect when the body is at motions. This dynamics is further classified into kinetics and kinematics. Kinematics is the branch of dynamics which deals the bodies in motions without reference to the forces which are responsible for that motions. Kinetics is the branch of dynamics which deals the bodies in motions and also the forces which are responsible for the motion of the body. The fundamentals of laws of mechanics are Newton's first law, Newton's second law, Newton's third law, Newton's law of gravitation, law of transmissibility of forces, parallelogram law of forces, Levy's theorem, and triangle law of forces. Newton's first law states that everybody is continuous in the state of rest or uniform motions in straight lines unless it is compelled by the external forces acting on it. Example, when the body is in motions, but remains in motions unless a force caused to come to the rest. Generally, the force which is acting in opposite direction of the motions, here it called, at the contact surfaces is called frictional force. Newton's second law is clear that the rate of change of momentum of the body is directly proportional to the impressed force and takes place in the direction of force acting on it. According to the Newton's second law, the force is equal to rate, it is the product of, the force is defined as the rate of change of momentum, mass into the rate of change of momentum is equal to mass into rate of change of velocity, hence it can be written as m into change in velocity v minus u divided by time, that is the rate of change of velocity. But the rate of change of velocity is also called the acceleration, hence force is the product of mass and acceleration. Newton's third law states that every action there is an equal and opposite reactions. Newton's law of gravitation states that every particle attracts every other particles in the universe with a force which is directly proportional to the product of masses and inversely proportional to the square of the distance between their centers. Newton's law of gravitation states that every particle attracts other particle in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance. It can be written as F is equal to G into M1 M2 divided by D square. Law of transmissibility of forces. The law of transmissibility of forces state that the rest or motion of the body is unaltered. That means the state of the body is unaltered. If a force acting on the body is replaced by another force of the same magnitude and directions acting anywhere on the body along with the line of action of the replaced force. Here the example now given. A force is acting at a point A on the body. If it is replaced at a point B now, at a point B, along the line of directions AB, that is the force which is acting, the effect of the force on the body it will not be changed now. Parallelogram law of forces. This law is useful for determination of resultant of two forces acting on a body. It states that if two forces acting simultaneously at a point be represented both in magnitude and direction of the two adjacent sides of a parallelogram, then the resultant is represented in magnitude and directions by the diagonal of the parallelogram passing through that point. Here, let P and Q are the forces acting at a point O as shown in figure. These two forces can be represented as two adjacent sides of a parallelogram, that is here OA and OB, both in magnitude and directions. Then the resultant of P and Q is representing the diagonal passing through point O, that is known as OC, both in magnitude and directions. Mathematically, R is equal to, we can write it as under root of P square plus Q square plus 2PQ cos theta. Now, the direction of resultant force with any one of the force, that is here P, is given by tan inverse of Q sin theta divided by P plus Q cos theta. Triangle of forces, it is a modification of parallelogram forces and also useful for determination of resultant of two forces both in magnitude and directions. According to this law, if the two forces are acting simultaneously at a point, be represented in magnitude and directions by the two sides of a triangle taken in order, then the resultant of these two forces can be represented as the closing side of the triangle but taken in opposite order. Here, the forces P and Q are acting at a point O, the figure. It can be represented as two sides of a triangle taken in order. Order means nothing but tail and head and tail and head now. The closing side of the triangle, that is here now, OC, is representing the resultant of P and Q but taken in opposite order. Polygon law of forces. This law is useful for determination of resultant of several forces acting on a point in both magnitude and directions by using graphical method. This law states that if a number of forces acting simultaneously on a particle be represented in magnitude and directions by the sides of a polygon taken in order, then the closing side of the polygon is represented both in magnitude and direction of resultant of all the forces but taken in opposite order. Here, let O be the point at which the five forces F1, F2, F3 and F4 and F5 forces are acting on it. Then the resultant of these five forces can be represented as now. Here the reference point is O. F1 is represented OA, and second B force can be represented here now. Third one and fourth one and fifth one. This is known as the closing side. This closing side is representing the resultant of all these 5 forces, but represented in opposite order. Here the particle is defined as infinitely small volume, but having a mass, and it is concentrated at a point now. Rigid body may be defined as the body which can retain its shape and size even if subjected to some external forces. But in actual practice, it is difficult to exist a rigid body. All the bodies will deform when the external forces are acting on it. But sometimes the deformation is very, very small and it can be negligible. Hence, for the sake of simplicity, all the bodies are treated as rigid bodies now. The definition of the force. When the force is acting on the body, it changes the motion of the body. That is, the body is at rest because of action of the forces. It may change its state now. Or when the body is in motion, it will again come to the rest position. And sometimes it also retard the motion of the body. Generally, it is called here now brakes. The characteristics of a force now. The force is always represented in magnitude. That means 100 newtons, 200 newtons, 250 newtons like this. It can be represented by the direction also. Hence, the force is treated as a vector quantity. That means it can be represented both in magnitude and directions. And the nature of the force, that is, what is the effect on the body when the force is acting on it. Sometimes it may be the force is like this. When the force is applied in this direction, like this, the length of the body is extension or elongates. This force is called here now pull force. Sometimes the force is applied like this also. This is called compressive force or push force. Sometimes the force is also acting over the body, which tends to rotate the body in clockwise or anti-clockwise directions. Here, that force is called here now bending force or the shear force when the force is acting along the surface of the object. That means nothing but depending on nature of the force, it can be classified as push force, pull force, and bending force, twisting force, and shearing force also. And the point at which the force is acting on the body. When the several forces are acting on the body, then they are called force system or the system of forces. The following system of forces are important here in this subject. These are classified, the force systems are classified into coplanar and non-coplanar forces. Coplanar forces means the line of action of all the forces lies in a single plane. Non-coplanar forces means the line of action of the forces may lie in 2 or more different planes or several planes also. These coplanar forces further divided into collinear. That means the line of action of the forces, here the one line, the one more line is there. Both are in the same line, but they may act in the same directions or in opposite directions. Concurrent. If the line of action of all the forces passing through a single point or the line of action of the forces intersect at one point, then the forces are called concurrent forces. Parallel forces, if the line of action of the forces parallel to each other, they may act in the same directions or in opposite directions, These forces are called parallel forces. Non-concurrent, non-parallel, that means the forces are not at all meeting at one point or not intersecting at one, and also not parallel to each other. That system of forces are called non-concurrent, non-parallel forces. Now, non-coplanar forces, already I told, if the line of action of the forces lies in different planes, that force system is called non-coplanar system. These are classified into again concurrent, parallel, non-concurrent and non-parallel. Here example, collinear is given. Here F1 and F2, F3 forces are there. All are acting in the same directions now. That here now, the line of action of the forces are in the same lines. Hence, this force system is called collinear, and all are acting in the same plane. These are called coplanar collinear forces. The second case is there now. F1 and F2, F3 are the line of action of the forces are passing through a point O as shown in figure. This force system is called coplanar concurrent force system. In this case, sometimes if required, extend the line of action of the forces to meet at a point now. Coplanar and parallel forces, here F1, F2, F3 are there now. They are acting parallel to each other. They may in the same directions or may in opposite directions. But if the line of action of the forces lies parallel to each other and single plane, then coplanar parallel force system. Coplanar non-concurrent, non-parallel. Here we have taken totally 4 forces. So the line of action of 4 forces are not at all intersecting in point 2. And these forces are not parallel to each other. Hence, these are called coplanar, non-concurrent, non-parallel force system. Resultant of force now. When a number of forces are acting simultaneously on a body, replaced by a single force, which will produce the same effect of all the forces which are acting on that body, the single force is called the resultant of all the 2 forces. The forces E, F, G, what we have considered, these are treated as a component of a resultant force. Composition of forces, the process of finding the resultant of several forces which are acting on a body is called composition of forces. Sometimes it is also called compounding of a forces. Method of for finding the resultant force. Okay, there are 2 methods are there to find the resultant of several forces which are acting on a body, both in magnitude and directions. They are graphical method. The second one is analytical method. It is also called method of resolution method. The graphical method. In this method, the forces which are acting on a body can be represented both in magnitude and directions, and the resultant force can be determined graphically. These are classified as now depending on number of forces acting on the objects. When the 2 forces are acting, the first 2 methods are applicable. One is a parallelogram of forces. The second one is a triangle of forces. When the several forces are acting on a body, the resultant of the force system can be determined by using law of polygon of forces. Parallelogram law of forces, it says that the 2 forces are acting simultaneously on a particle at a point O, can be represented as both in magnitude and direction of 2 adjacent sides of a parallelogram. Then the diagonal which is passing through that intersection of parallelogram is representing the resultant of these two forces both in magnitude and directions. Here two forces are there now, P and Q. They are acting at a point O. The resultant of these two forces can be represented as two sides of a parallelogram. Then the diagonal which is passing through that intersection here, it is representing the resultant of these two forces both in magnitude and directions. Triangle law of forces, it states that when the two forces are acting on a body, can be represented as two adjacent sides of a triangle taken in order. The closing side is representing the resultant of these two forces but acting in opposite order. Here P and Q are the forces acting at a point O. These two forces can be represented as two adjacent sides of a triangle taken in order. Order means nothing but tail and head fashion. That is here OP, and of course the Q, it is there now. It is there, tail, and head. Then the closing side of the triangle, that is here OC, it is representing the resultant of these two forces, and it is represented as R, but in opposite direction. That means here it is nothing but one direction it is there, one more directions, but here it is in opposite direction is there now. When the several forces are acting on a body, the resultant of force system can be determined graphically by using polygon law of forces. It states that when the several forces are acting on a body, can be represented as sides of a polygon taken in order. Then the closing side of the polygon is representing the resultant of all the forces taken in opposite order. Here totally 5 forces are there now, which are represented as here A, B, C, D, E, both in magnitude and directions. These can be represented as now, it is the starting point, or unit is there. A force, here one directions now. B force, taken in order. C force, like this. And D force, again. E force, like this. That means all the forces are taken, represented as sides of a polygon taken in order now. The closing side is there now. This is nothing but treated as closing side now. Already 5 forces are there now, which is representing resultant of all the forces but taken in opposite order. The resolution of a force, that is, this method is useful for finding the resultant of several forces which are acting on a body, that is system of forces, by using analytical method. In this method, the force is resolved into two components, preferably which are right angles to each other, and one is in parallel, that is along the x directions, one more is along the y directions. That is when the force is resolved into two components, rectangular components, these are called here now resolution of the force now. In order to determine the resultant of several forces acting on a body, resolve all the forces into two components. Preferably one is along the x directions, one more is along the y directions. The algebraic sum of all the forces which are acting along the x directions are treated as the x component of the resultant force. Similarly, resolve all the forces along the y directions. The algebraic sum of all the forces which are acting in y direction, that is vertical direction, is treated as the vertical component of the resultant force now. These are represented as now H is the horizontal component, sum of the sigma V representing the sum of the vertical component. Then R is equal to, that is the magnitude of resultant force is given by under root of sigma H square plus sigma V square now. The direction of resultant force with the horizontal again given by tan theta is equal to sigma v divided by sigma h now. Free body diagram. In engineering applications, always the body is having supports in order to perform certain functions. These supports, it may be in the form of rollers or it may be in the form of hinges. Sometimes it may be in the form of fixed and so on. The body in which the body under consideration is free from all the contact surfaces and shows all the forces acting on it, including the reactions at the contact surfaces, is called free body diagram. Here, the body is there now, it is supporting with the roller. When the body is represented, again assume just one force is also there on it now. When the body is represented here now, with the forces which are acting on it, as well as the reactions offered by the support on the body, that is nothing but here the roller is there, it is preventing its motions in downward directions. And so, the reaction is kept here now, that is the F now, which is equivalent to the reaction offered by the roller on the body. Then this body is treated as a free body diagram. That means the body which is having all the supports are replaced by equivalent to reactions offered by that supports and also represented the forces which are acting on it. Then the body here said to be free body diagrams. This free body diagram is most important to find the effect of forces as well as the reactions which are acting on it now. Here example we are taken now. The body is lying on the ground is there now, or the table it is there. That is the body is prevented its motion downward directions. The weight is acting vertically in downward directions. Hence the free body diagram is represented as here weight is acting downward direction, the force is already there, and also represented the reactions offered by the support, that is the table surface on the body, which is preventing its motion downward directions. That is called here now the reactions. Here the ball is hanged vertically downwards by using the rope it is there. The body is here prevented its motions downward directions as well as its movements toward the left hand side now. And so here the T is representing now the tension in the rope. The tension is the reactions which is within the stem. It is always acting away from the object as shown in figure. Moreover, the reactions offered by the surface, that is, it is preventing its motions toward the left hand side. Hence, the reactions are already shown, that is R, it is acting toward the right hand side to prevent its motions. The W is nothing but representing the weight of the body now. Equilibrium of forces and the equilibriant. Here when the several forces which are acting on a body, all the forces are replaced by a single force which will having the same effect of all the forces. That single force is treated as the resultant of all the forces. But if the magnitude of the resultant force, if it is equal to 0, then the body is said to be in equilibrium. That means when the several forces are acting on a body, the resultant of all the forces must be equal to 0. Then the body is said to be in equilibrium. Now the resultant of coplanar forces acting on a body is 0 when here we are taking the forces are acting here in so many forces, 4 forces are acting. If the body is in equilibrium position means the resultant of all the forces, that is 4 forces which are acting on a body should be equal to 0 now. It will happen because according to the resolution of forces or analytical method to find the resultant of several force system, that is the algebraic sum of all the forces which are acting in horizontal direction should be equal to 0, and also the sum of the vertical forces, that is the sum of the components of vertical forces, also equal to 0. That means sigma h is equal to 0 and sigma v is also equal to 0 now. This equation is only applicable when the line of action of all the forces passing through a single point, that is treated as concurrent forces. But sometimes if the forces are not concurrent, in order to keep the object in equilibrium position, we required 3 conditions. One is sigma h is equal to 0. The second one is sigma v is also equal to 0. The third equation is required. The algebraic sum of moments created by all the forces at any point should be equal to 0. That means sigma m is also equal to 0 required. Now equilibrium. Here sometimes when the forces are acting on the body, it shows a certain effect on it. Here all the forces which are replaced by single force, then it is called resultant of all the forces. When a force, single force which is acting on a body, which keep that body in equilibrium position, the single force is here called equilibriant. Single force. All the forces are acting on a body. It will having certain effect now. That force is here called a resultant force, which is having both magnitude and directions. It is having certain effect now. But when you are taking a single force, which will keep the body in equilibrium position, that single force is called equilibriant. That means the equilibrium is always having the magnitude of resultant of all the forces, but it should be act in opposite direction of the resultant force which is acting now. Leibniz theorem. If 3 coplanar forces acting at a point be in equilibrium, then each force is proportional to the sine of the angle between the other 2 forces. Here P, Q, R, these are the forces acting at a point O and keeping the body in equilibrium position. According to Leibniz theorem, the each force is proportional to the sine of the angle between the 2 other forces now. Example here there, P force is there now. The sine of the angle remaining 2 forces means Q and R is there, which can be represented as alpha now. Similarly, R force is acting now. The angle between the remaining 2 forces P and Q is represented as here gamma now. Q force is there now, which is acting. The angle between the other remaining 2 forces is represented as beta now. That is according to the Leibniz theorem. Each force is proportional to the sine of the angle between the other two forces. So P nothing but sine alpha is the proportional to, again that is nothing but constant. It can be written as Q divided by sine beta or R divided by sine gamma, which should be equal to always the constant. That means each force is directly proportional to the sine of the angle between the other two forces. This principle is called Lem's theorem. It is only applicable when three forces are acting on the body and the body is in equilibrium. Okay, types of equilibrium now. A body is said to be in equilibrium when it comes back to its original position after it is slightly displaced from its position of rest. In general, following are the three types of equilibrium. One is stable equilibrium. In stable equilibrium, a body is said to be in stable equilibrium if it returns back to its original position after slightly displaced from the position of rest now. As we are there, just when you give just a small force on it to displace from its original position now. So just it goes up to, that is the dotted line which is represented here now. After removal of the forces, maybe it is having slight oscillations, but finally come to its original position after coming to the rest now. So this is called stable equilibrium. Here one more is the unstable equilibrium. Assume the body is resting on convex surface. It is resting. When you applied small force on it now, similar to the stable equilibrium, but after that it will further move away from its original position. It will not come back to its original position now. This type of equilibrium is called unstable equilibrium. That is, a body is said to be unstable equilibrium if it does not return back to its original position and yields further away after slightly displaced from its position of rest. And neutral equilibrium. A body is said to be neutral equilibrium if it is occupies new position, that is here now, here one point it is there, yes it goes, this new position after slightly displaced from its position of rest. So this equilibrium of forces here now, types of equilibrium classified into three types: stable equilibrium, unstable equilibrium and neutral equilibrium. Moment of a force. The effect of moment of force always tends to rotate the body in which direction it is acting. The moment of force is a vector quantity, is equal to the product of force and the perpendicular distance between the reference point to the line of action of the force at which they are acting. Mathematically, it can be represented as now m is equal to p into l now, where m is known as moment, which is equal to product of p into l, where p is the magnitude of force, l is the perpendicular distance between the point. It is the moment is required to determine and the line of action of the force. Varignon principle, or it is also called law of movements. Generally, it is useful for determination of resultant of parallel forces acting on a body. It states that if a number of coplanar forces are acting simultaneously on a particle, the algebraic sum of all the forces about any point is equal to the moment of their resultant force about the same point. The couple, here when a pair of two equal and unlike forces of equal in magnitude, with the line of action of forces are parallel to each other, acting on a body, it will execute a couple. Assuming we are now A and B is representing an object. The forces P and P are acting at B and B, at A and B, which are parallel to each other and separated by distance. Then the resultant of these two forces may be the zero, but since they are now separated, it will always execute a couple now. That is, tends to rotate the body AB in clockwise directions. The clockwise movements generally treated as positive couple. If the body tends to rotate the body in anti-clockwise directions, that movements are treated as a negative couple for determination of the movements created by the resultant of all the forces. Okay, these are the references I have taken now for covering the definition of entire first unit. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.